Alright, so in this video I'm going to be going through how to graph this first example. This is a secant graph that we're going to be producing here, and I'm assuming at this point that you've already walked through all of the notes here and you're ready for example 1. I am going to be referring back to some of these items. I'm also going to be using the same reference information that's kind of down here, and I'll talk through this really quick. I'm going to be using these key points. You'll notice that all these zeros and ones are the same as what the sine patterns and cosine patterns would have been, since cosecant is going to be based on sine and secant is going to be based on cosine. So again, I'll touch base back with this pink sheet once I'm actually getting into writing the points. All right, so I'm going to start things off as always by figuring out the period, and again the period formula is going to be the same as the period formula for sine and cosine, so it's going to be 2 pi divided by b. B here is 1, so that means my period is just going to be 2 pi. Alright, that is going to go at the bottom of the table, 0 is going to go at the top, which means I cut 2 pi in half, I can get pi. Cut that in half, I can get pi over 2. And then if I'm thinking between 1 and 2, halfway between would be like 1.5 or 3 pi over 2. All right, and then I'll go ahead and start labeling my axis over here, just like we're used to. We're going to need to graph 2 cycles. These axes you are going to have to label like what we did for the sine and cosine graphs. So 2 pi, since this will be the end of 1 cycle here, that's going to go halfway. Double that, and I'll get the end of a second cycle. Halfway between 0 and 2 pi would be pi, also the same as that row in our table. And then if I'm thinking 1 pi, 2 pi, 4 pi, 3 pi would fall between. Halfway between 2 and 4. All right, amplitude, same as it's always been, is going to be 3. And I'll come back to the shifts here in a moment. What I'm going to start by doing first is writing in my cosine points. So my cosine points, and if you want a refresher on that, that's going to be right here on my pink table, 1, 0, negative 1, 0, 1. Why am I writing cosine? Well, cosine is the reciprocal of secant, and secant is the reciprocal of cosine. So I'm going to be using cosine to create this graph. So again, 1, 0, negative 1, 0, and 1 for my points. Now, you can, right at this moment, change these zeros. If you took the reciprocal of those are going to change to undefineds, and those are going to become your asymptotes, or you can carry it through all the way. I'm going to recommend carrying it through all the way so that you have the full graph and the full points to utilize. And it'll kind of help make your cosine and your secant graphs. So still think of these as zeros, but just know those are going to become where the asymptotes are. All right, so then what do we do next? Well, same as we've always done, we're going to multiply by 3 in this next column and subtract 1. So this is going to become 3, 0, negative 3, 0, and 3. And again, I did continue using these points. And then this, I'll subtract 1, 2, negative 1, negative 4, negative 1, 2. All right, double check my math. We're good to go there. All right, now we are ready to graph. So this is where I'm going to be using some different colors here to kind of distinguish between my cosine graph and my secant graph. So I'm going to start by graphing my cosine graph in blue. So 0, 2 would be right here. Pi over 2 and negative 1 would be here. Pi and 3 pi over 2, excuse me, pi and negative 4. 1, 2, 3, 4. There. 3 pi over 2, negative 1 is going to be there. And 2 pi and 2 is going to be right up here. And then I'll make 2 cycles. Try to get this nice and perfect. Okay, so then I'm going to dash this line. This is my cosine graph. Good practice, keeping our skills sharp on cosine and sine. Okay, now where would my sinusoidal axis be? My sinusoidal for that graph is here at negative 1. That's also my vertical shift. So I can write down 1. You can even write your sinusoidal off to the side. Y equals negative 1. Okay. Everywhere that your sinusoidal crossed this cosine graph, so here, 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 and here, you're going to be placing asymptotes. So I'm going to place these vertical lines in each of those spots. All right. Asymptotes are going to go in each of those spots. And those are the same spots that we would have had asymptotes if I had carried this through as an undefined value. Now, I needed all 5 points so that I had more to graph, but that would have carried through as undefined and become my asymptotes. So I'll go ahead and jot down my asymptotes. My asymptotes are going to be x equals pi over 2 and x equals 3 pi over 2. Okay, cool. Let's go ahead and graph our secant. So secant is going to use as its key points the 3 points from our table that we did not mark already as asymptotes. So 0, 2, pi and -4, and 2 pi and 2. All right, so you're going to draw kind of a portion there of a parabola, if you will. Here, it'll be a parabola kind of like it's flipped down. Here, a parabola flipped up. Here, one that's flipped down. And there, one that's flipped up. And again, what I've drawn in red is the secant graph. Cool. All right, let's fill out the info and wrap this one up. There is no phase shift. I'm never going to have you do one with a phase shift that we're graphing by hand, so you're going to be marking those out for all of those. None for any of those. All right, domain. Remember, domain is the list of things x can't be, so it's going to be your asymptotes. So what we listed as our asymptotes here would give us undefined values if we flip those to their reciprocals. So we're going to say x cannot be pi over 2 and 3 pi over 2. Cool. All right, range is the tricky one. This is kind of new. Remember, we're pointing down at -infinity up to where that parabola cuts off. So this is at -4. Then our restart here, that looks like 2, and then up to infinity. And your points should match up here as well. That y column will correspond. All right, to write this, and again, this information is here if you want a model of how the structure should look. And it also should be on your notes there as well. All right, so we're going from -infinity to where it cuts off. I'm calling that the stop. Bracket, because we do actually have dots there. The U, then bracket to where it starts up again to infinity. Cool. All right, I would take questions at this point, but I'm not there, so I'm sorry. I'll be back. And I'll be able to answer questions then. All right, videos are going to carry on with example 2 and example 3, so you can check those out for the rest of the notes.